On July 29, 1801, in the pre-dawn waters off Brest Harbor, France, Robert Fulton descended into a copper-clad vessel that would redefine naval warfare. The American inventor, 36 years old, had spent 2 years designing this machine. The Nautilus, 21 feet long, shaped like a cigar, powered by a hand-cranked propeller. 4 small windows provided the only light. A collapsible sailmast for surface travel. A compressed air system that could sustain 3 men for 4.5 hours underwater. Napoleon Bonaparte's naval commission waited on the shore. They had dismissed Fulton's proposal twice before, called it fantasy, impossible, but Fulton had built it anyway, using his own limited funds and borrowed money. Now he needed to prove something no one had ever demonstrated. A vessel could operate beneath the surface, approach enemy ships undetected, and deliver a fatal blow. The hatch sealed with a metallic clang. Darkness swallowed everything except the faint glow from the viewing ports. Fulton's 2 crew members positioned themselves at the propeller cranks. The inventor checked his depth gauge, a simple pressure meter of his own design. His breathing apparatus, leather bags filled with compressed air, enough oxygen for the planned dive time. He gave the signal, the crew began cranking, the Nautilus slipped beneath the surface. Robert Fulton wasn't supposed to be here. Born in 1765 in Lancaster County, Pennsylvania, the son of Irish immigrants, he'd shown early talent for mechanical drawing and painting. At 21, he'd sailed to London to study art under Benjamin West. For years, he painted portraits and landscapes. Modest success, moderate income. But his mind kept drifting to problems of engineering and transportation. By 1797, Fulton had abandoned art entirely. He'd moved to Paris, immersed himself in the city's scientific community, and become obsessed with a singular idea: vessels that could travel underwater. The concept wasn't new. David Bushnell's Turtle had attempted to attack British ships during the American Revolution in 1776. It failed. The design was too crude, the execution too ambitious for its technology. Fulton studied Bushnell's mistakes. He spent months calculating displacement, buoyancy, pressure resistance. He sketched dozens of hull designs, tested materials, consulted with French engineers about propulsion systems and air supply mechanisms. He wasn't just trying to build a submersible, he was trying to build a weapon. In 1798, Fulton approached the French Directory with his proposal. Revolutionary France was at war with Britain. The Royal Navy controlled the seas, enforced brutal blockades, strangled French commerce. Fulton offered a solution: submarines that could approach British warships invisibly, attach explosive charges to their hulls, and retreat before detection. Underwater assassins. The Directory rejected him. Too expensive. Too experimental. The French Navy's traditional officers found the entire concept distasteful. Ships fought in open battle, cannon against cannon, honor against honor. Attacking from beneath the waves seemed cowardly. Fulton didn't give up. When Napoleon seized power in 1799, the inventor submitted his proposal again. This time, he emphasized cost efficiency. A single submarine could destroy a ship of the line worth hundreds of thousands of francs. The weapon cost a fraction of that to build. Naval warfare could shift from expensive fleet actions to economical covert strikes. Napoleon's Minister of Marine, Pierre-Alexandre Laurent Forfait, authorized a trial, limited funding. If Fulton could build and demonstrate a working submarine, the government would consider full support. Fulton began construction in Paris in late 1799. He worked with Marc Brunel, a French engineer who would later design the Thames Tunnel. Together, they refined the hull shape, an ellipsoid form that minimized water resistance. They designed the propulsion system, a hand-cranked 4-blade propeller positioned at the stern. They developed the ballast system, water tanks that could be filled to descend and pumped out to ascend, controlled by a manual pump and valve arrangement. The hull was constructed from copper sheets over iron ribs. Copper resisted corrosion in seawater, maintained structural integrity under pressure, and could be shaped precisely. The viewing ports were thick glass, sealed with pitch and cork gaskets. The compressed air system used leather bladders filled at surface pressure, stored inside the hull. The weapon delivery mechanism was Fulton's most innovative element. He called it a torpedo, a term he coined, derived from the torpedo fish that delivers electric shocks. His torpedo was a copper case, containing approximately 170 pounds of gunpowder, equipped with a clockwork detonator. The submarine would tow it on a line, maneuver beneath an enemy ship, attach it to the hull using a screw mechanism, activate the timer, and retreat. By June 1800, the Nautilus was complete. Fulton conducted initial tests in the Seine. The vessel submerged successfully, maintained depth at 25 feet, and surfaced without incident. The crew could breathe comfortably for over 4 hours. The propeller system worked, though laboriously. Hand cranking generated a speed of roughly 2 knots submerged, 3 knots on the surface with the sail deployed. But the French government had lost interest. Napoleon's attention had shifted to land campaigns in Italy and Egypt. Naval warfare seemed secondary. Funding dried up. Fulton received no official support, no payment, no encouragement. He decided to stage his own demonstration, something so dramatic that Napoleon couldn't ignore it. On July 29, 1801, Fulton positioned the Nautilus in Brest Harbor. His target, a small sailing vessel anchored offshore, provided by sympathetic naval officers. The plan was simple: submerge, approach undetected, attach a torpedo to the hull, retreat, and let the explosion speak for itself. At 5:30 a.m., the Nautilus dove. The water outside the viewing ports shifted from pale blue to deep green to near black. Fulton monitored the depth gauge, 20 feet. The compressed air bladders released oxygen slowly through a valve system he controlled manually. The air had a metallic taste, slightly stale, but breathable. The crew cranked steadily. Fulton navigated by compass and dead reckoning. Underwater, visibility extended perhaps 15 feet. In the murky harbor water, he couldn't see the target vessel yet. He surfaced briefly, checked position, noted the target bearing 200 yards northwest. He submerged again. The cranking continued. Exhausting work. Each man rotated every 10 minutes to prevent muscle fatigue. Sweat dripped despite the cold water surrounding the hull. The interior temperature remained tolerable, but humidity condensed on every metal surface. After 17 minutes underwater, Fulton spotted the target's hull, a dark mass against slightly lighter water. He maneuvered the Nautilus beneath it, positioning the submarine directly under the keel. His assistant released the torpedo from its external rack. Fulton manipulated the attachment mechanism, a long pole with a screw auger at the end, designed to penetrate the wooden hull, just enough to secure the explosive. The auger bit into the wood. 3 full rotations. The torpedo was fixed. Fulton activated the clockwork timer, set for 15 minutes, and ordered the retreat. The crew cranked furiously. The Nautilus descended to 30 feet and moved away from the target zone. They surfaced 400 yards distant. Fulton opened the hatch. Fresh air flooded in, sharp and cold and magnificent. He climbed onto the small deck. The target vessel floated peacefully in the early morning light. The harbor was quiet, except for distant seabird calls. Then the explosion. A column of water erupted skyward, 60 feet high. The blast echoed across the harbor, rattling windows in Brest. Wooden fragments rained down. When the water settled, the target vessel was gone. Completely destroyed, reduced to floating splinters. The French naval officers on shore stood silent. They'd witnessed something unprecedented. A ship destroyed by an invisible attacker. No warning, no defense, no chance of retaliation. Fulton repeated the demonstration 3 more times over the following weeks. Each time, the Nautilus performed flawlessly. Submerged approaches, successful attachment, complete destruction of the target. The Naval Commission filed their report to Napoleon in August 1801. The submarine worked, the technology was proven. The strategic implications were staggering. Napoleon's response came in October. He dismissed the entire project. The official statement called the submarine dishonorable as a weapon of war. Naval combat required visible opponents, equal chances, mutual risk. Attacking from beneath the surface violated these principles. France would not adopt such tactics. The reality was more complex. Napoleon's naval minister, Denis de Creye, who replaced Forfait in 1801, was a traditional naval officer who despised innovation that threatened established fleet structures. Admirals argued that submarines would make their expensive ships of the line obsolete. The naval bureaucracy united against Fulton's invention. There was also a practical concern. If France developed submarine warfare, Britain would respond in kind. The Royal Navy had far greater resources, better engineers, more advanced metallurgy. A submarine arms race would likely favor Britain. Napoleon saw the strategic danger. Fulton, frustrated and nearly bankrupt, approached the British. In 1804, he travelled to London and offered the submarine technology to Britain's Admiralty. Surely they would recognise its value against French and Spanish fleets. The British response was even more hostile. Lord St. Vincent, First Lord of the Admiralty, called Fulton's submarine a device for cutting throats. The Earl of St. Vincent declared that anyone who developed such weapons was an enemy of humanity. The Admiralty rejected Fulton's proposal outright, though they did pay him $15,000 to suppress his designs and prevent France from acquiring them. Fulton demonstrated the Nautilus one final time in October 1805 off the English coast, attempting to attack French ships in Boulogne harbour. The mission failed. Rough seas prevented the submarine from maintaining stable depth. The target vessels moved before Fulton could position for attack. The Royal Navy offered no support. He abandoned submarine development entirely. The Nautilus was dismantled in 1806. Fulton returned to America and focused his energy on a project with more immediate commercial viability: steamboats. His designs would revolutionize river transportation. He'd become famous for the Clermont, the first commercially successful steamboat service on the Hudson River. But the submarine remained his unrealized vision. Fulton died in 1815 at age 49, from pneumonia contracted after rescuing a friend who'd fallen through ice. His submarine designs were filed away, considered historical curiosities. The world wasn't ready for underwater warfare. The technology existed. The tactical advantages were obvious, but the psychological and institutional resistance was insurmountable. It would take another 50 years before submarines returned to naval warfare. During the American Civil War, both Union and Confederate forces experimented with submersibles. The H.L. Hunley became the first submarine to sink an enemy warship in combat, destroying the USS Housatonic in 1864. The Hunley's crew drowned immediately afterward. The vessel never returned from its mission. By World War I, submarines had become decisive weapons. German U-boats nearly starved Britain into surrender, sinking millions of tons of merchant shipping. The tactical principles Fulton had demonstrated in 1801, stealth, surprise, devastating attacks from concealment, dominated naval strategy. The irony wasn't lost on military historians. Napoleon and the British Admiralty had rejected submarines as dishonorable. A century later, their nations deployed submarines by the hundreds, conducting unrestricted warfare that killed thousands of civilian sailors. Fulton's Nautilus had proven that technology advances regardless of moral objections. What seemed dishonorable in 1801 became standard practice by 1914. The weapon exists, someone will use it. Ethics follow necessity. The Nautilus specifications seem primitive now: hand-cranked propulsion, 4-hour air supply, 2-knot maximum speed. But Fulton had solved the fundamental problems: pressure hull design, ballast control, crew survivability, weapon delivery. Every submarine built since then is a descendant of his work. Modern nuclear submarines can remain submerged for months, travel at 40 knots, carry ballistic missiles capable of destroying continents. They patrol silently in ocean depths, invisible, undetectable, waiting. They are the ultimate expression of what Fulton demonstrated in Brest Harbor: power without visibility, threat without warning, the ability to destroy without being seen. Robert Fulton saw it first. He built it with copper and iron and his own borrowed money. He proved it worked. The world rejected him not because his invention failed, but because it succeeded too completely. It revealed a future no one wanted to acknowledge. In July 1801, a man descended into darkness beneath French waters and changed naval warfare forever. The world just wasn't ready to admit it yet.